Assalamualaikum and hi, my name is Asha Najwa binti Marhaidan, and in this video, me and my groupmates will be presenting about the experiment on finding the percentage of metal in an alloy by using back titrations. So, let's get started. First of all, we have to know that volumetric analysis consists of acid-base titration, precipitation titration, complexometric titration, and redox titration. There are three types of other titration, which are blank titration, direct titration, and back titration. Back titration is a titration where the concentration of an analyte is determined by reacting with a known amount of excess reagent. The remaining excess reagent is then titrated with another second reagent. This titration requires a two-step reaction, hence two balanced chemical equation. The mole of reagent reacted can be found by subtracting the initial mole with the excess mole.
Back titration is an important analytical technique used when the reaction between two substances is too slow or when it is difficult to obtain sharp endpoint. It involves adding an excess of a known reagent to react with the analyte, followed by titrating the remaining excess reagent with a standardized solution. This method is particularly useful when one of the reactants is volatile or when there is no suitable indicator to indicate the completion of the reaction. So back titration allows for accurate determination of the analyte's concentration, overcoming the limitation posed by these factors. Here are the procedural steps in back titration to find the percentage of metal in an alloy. So first, weigh out about 4 grams of alloy mixtures and record the mass. Second, dissolve the alloy mixture in 50 ml of 1 molar H2SO4. Number 3, transfer the mixture into a volumetric flask and dilute it with distilled water up to 250 ml. Number 4, shake the volumetric flask upside down to ensure homogeneous mixture. Number 5, pipette 25 ml of the mixture or a liquid into a conical flask. Number 6, titrate the mixture with standardized solution of sodium hydroxide using phenolphthalein indicator. This also shows that sodium hydroxide serves as titrant in this experiment. Number 7, record the period reading. Number 8, pipette 25 ml of 1 molar H2SO4 into a conical flask. Number 9, titrate the 1 molar H2SO4 with excess sodium hydroxide and record the period reading. So here are the results of the experiment to be analyzed, in which the reading of the actual accurate weight of the alloy mixture is actually 3.6 grams. So when we repeat the experiment for 3 times, so we got 3 reading in which give us the average volume of sodium hydroxide, which is 14.1 centimeter cube.
For the first step of calculation for this back titration experiment started by finding the total or initial mole of acid sulfuric. The molar of acid sulfuric, which is 1 molar, will be multiplied by the volume of acid sulfuric that has been used to react with iron, which is 0.05 liter, and we will get 0.05 mole. So to find the mole of sodium hydroxide that react with excess acid sulfuric, the molar of the sodium hydroxide, which is 0.1 molar, will be multiplied by the volume of sodium hydroxide that has been neutralized by acid sulfuric, which is 0.0141 liter, which is equal to 0.00141 mole. Okay, next, for the next calculation, to find the mole of excess acid sulfuric, we must compare the mole of sodium hydroxide with acid sulfuric. So 0.00141 mole that represented the 2 mole of sodium hydroxide is equal to 7.05 times by 10 to the power of negative 4 mole, because 0.00141 mole must be divided by 2 because we want to find 1 mole of acid sulfuric. And then there is the mole of 25 centimeter cube of acid sulfuric. But to find the 250 centimeter cubic of acid sulfuric, so 250 centimeter cubic will be multiplied by 7.05 times by 10 to the power of negative 4 divided by 35 centimeter cube. And then we get the mole of 250 centimeter cube of acid sulfate, which is 7.05 times by 10 to the power of negative 3 mole. And next, to find the mole of reacted acid sulfuric, 0.05 mole, which is equal to the initial mole of acid sulfuric, will be minus by 7.05 times by 10 to the power of negative 3 mole. And then we will get 0.04295 mole of reacted acid sulfuric.
After finding the mole of reacted H2SO4, we can now find the mole of iron by comparing the mole of reacted H2SO4 with iron. The ratio of mole of iron and reacted H2SO4 is 1 to 1. As such, the mole of iron is the same with mole of reacted H2SO4 at 0.04295 mole. Next, we can find the mass of iron reacted by using the formula mass equals molar mass times mole. The molar mass of iron is 56 gram. As such, we multiply 0.04295 mole with 56 gram per mole to obtain the mass of iron, which is 2.4052 grams. Finally, we can find the percentage of iron in the alloy by using the formula of mass of iron 2.4052 gram over total mass of alloy 3.6 gram times 100%, where we can get the percentage of iron at 66.8%.
Assalamualaikum and hi, my name is Siti Aisyah Puspitasari, painting theory. Next, the acidity or basicity calculation begins when the amount of moles of a sodium hydroxide and sulfuric acid are known. The stoichiometric method is used to calculate the amount of sulfuric acid used in a titration by following the ratio of a sulfuric acid and a sodium hydroxide. Following that, the entire bulk volume in the conical flask is estimated to determine the molar concentrations of a sodium hydroxide ion because the number of moles of a sulfuric acid is less than the amount of sodium hydroxide ion. Hydroxide ion has a molar concentrations of a 0.018 molar. The pH is a 12.3 and the pOH is a 1.745. The titration curve for both strong acid and a strong base is illustrated in a slide. This graph describes the sodium hydroxide running into the sulfuric acid in a conical flask. According to the graph, the pH solutions of a sulfuric acid before the additions of the salts is 1.745. The pH steadily increases as the sodium hydroxide titrate is used. There is a slightly increase before and after the equivalent point. As the more sodium hydroxide is added, the pH gradually increases. Then, the titration was completed when 0.018 molar of a sodium hydroxide was determined by reacting with 25 ml of excess sodium hydroxide.